Hi, in this video, let's see the derivation for angle between radius vector and the tangent. For this first, we have to construct the diagram and consider P r comma theta be any point on the curve. R is equal to f of theta. So now, just see this P of r comma theta. So what do you mean by P of r comma theta? It makes an angle theta and from the pole to the point, this distance is r. So OP is equal to R. So this is the point on the curve. So this is the curve. So P of R comma theta be any point in the curve. And now PL be the tangent to the curve at P. So at P I am drawing a tangent. So this, I have to draw straight. So this PL is the tangent to the curve at P, subtending an angle psi. So they are talking about this angle psi with the positive x-axis. So they are saying that the angle is psi in the positive direction of x-axis. Initial line is nothing but x-axis. And phi be the angle between the radius vector OP and the tangent. So this is your radius vector and this is your tangent, and in between this the angle is nothing but phi. Okay. So this is the construction. So if OPL is phi, then automatically this angle is also phi. Okay. So now, according to the basic rule, that is the geometry, what is that? Exterior angle is equal to sum of the interior opposite angles, right? So sum of interior opposite angles. So this is your exterior angle is psi. This is equal to this angle plus this angle. So psi is nothing but phi plus theta. Okay. So now we are going to find the tan angle for it. Now if you see, tan psi is equal to tan theta plus phi. Okay. So tan A plus B formula, what is that? In the place of A I have phi, in the place of B I have theta. Tan A plus tan B by 1 minus tan A tan B. So we've just applied the formula. And this is the corresponding Cartesian coordinate if the polar curve is r comma theta. So I will write x as r cos theta and y as r sin theta. So here, if you notice, r is a function of theta, of course. But here, we are considering that x is also a function of theta and y is also a function of theta. So we are considering this as a parametric equation in terms of theta, and we are going to find tan psi, that is nothing but dy by dx. This is nothing but the slope of the tangent BL. Now I am considering this numerator y also with respect to theta and denominator x also with respect to theta. That is why we are writing this tan psi is dy by d theta divided by dx by d theta. So already, as I told you, x and y I am treating as a function of theta. What is y? Y is already written. Y is equal to r sin theta. We have written it. And what is x? X is r cos theta. We have written this. Now we are going to differentiate with respect to what? Theta, and you can see a u-v rule. Keep u, that is r as it is. Differentiation of sin theta is cos theta. And keep sin theta as it is. And differentiation of this r is nothing but r dash. So whatever uv is there, keep u, differentiate v. That is differentiation of uv is equal to keep u, differentiate v plus keep v, differentiate u. This is the basic rule. Okay. So this I have written r dash. This r dash is nothing but dr by d theta because we are differentiating with respect to theta. So we will get one r dash term which is nothing but dr by d theta. Similarly, keep r as it is. Okay. And cos theta differentiation is minus sin theta. That is why this negative sign is here in the beginning. Plus keep cos theta as it is, and r if you differentiate r dash. So just a uv rule. So we have simplified tan psi, and now we are dividing it by r dash cos theta. Why I have to divide it by r dash cos theta? Already we have derived tan psi as tan phi plus tan theta divided by 1 minus tan phi tan theta. This already we have done it in the beginning. by saying that psi is equal to theta plus phi, and then tan A plus B formula we have used. So now if you see this, already we are going to compare, means this term is 1 is there. So I want to bring one more 1 here, that is positive 1 in the denominator. Already we have minus r sin theta in the denominator, and one more term r dash cos theta. Out of this, if I divide by r dash cos theta, this term will become 1. So it is easy for me to compare this with the existing equation. So numerator and denominator I am dividing by r dash cos theta. So numerator r cos theta by r dash cos theta will get cancelled, and I will get r by r dash. Now r dash and r dash will get cancelled. Sin theta by cos theta is nothing but tan theta. And denominator minus r by r dash, okay, sin by cos will become tan. So this is the second term. And this term only I said r dash cos theta by r dash cos theta, completely it will get cancelled and you will get 1. So now it is easy for me to compare with this equation. Okay, in the place of tan theta, I have one more tan theta. Okay, so in the place of tan phi, what we have? R by r dash. So tan phi is nothing but, I am just comparing the numerator and denominator term. Denominator 1 is there as it is, tan theta as it is. Then in the place of, again, denominator also, if you check tan phi, in the place of tan phi, what I have? R by r dash. So here we have tan phi. So tan phi is nothing but r by r dash. What is r dash? R dash is nothing but dr by d theta. So from this, I'm just substituting r dash as dr by d theta. If it comes to the numerator, it will flip and you will get r d theta by dr. So this is the expression for the angle between the radius vector and the curvature. So if tan phi is r d theta by dr, we can write 1 by tan phi is nothing but cot phi. So reverse of it, 1 by r into dr by d theta. So this is a very, very important proof, and continuation of this is nothing but the length of perpendicular from the pole to the tangent. Okay. So in case if they ask us to prove 1 by p square is equal to, with usual notations, they may say with usual notations, prove that 1 by p square is equal to 1 by r square plus 1 by r per 4 dr by d theta the whole square. If they ask us to prove like that, then again we will continue the proof, that is the length of the perpendicular from the pole to the tangent. And again, if you see OB the pole, and this is the initial line, that is OL is the initial line, and P r comma theta be any point on the curve. Obviously, this is R, okay, and this angle is theta. The same thing I'm writing again. And now I'm going to draw a perpendicular here. Now it should be perpendicular from the pole. If I draw a line to this should be perpendicular to it. So perpendicular from the pole to the tangent at P, and phi be the angle made by the radius vector with the tangent. This angle is phi, and this should be perpendicular, that is 90 degree. So this ONP is 90 degree and this LOP is theta, same thing. Now you can see a right angle triangle, that is ONP. At N we have 90 degree. So sin phi is opposite side by hypotenuse. Your hypotenuse is nothing but OP, which is nothing but R. Correct? And what is ON? This length I have written P. So sin phi is equal to P by R, which implies P is equal to R sin phi. Sin phi is equal to ON is nothing but P and OP is nothing but R, which implies R is equal to P sin phi. From this we will continue. So we got P is equal to R sin phi. So what is 1 by P? 1 by R sin phi, which is nothing but 1 by R cosecant phi. So what is 1 by P square? 1 by R square cosecant square phi, and which is nothing but 1 by R square into cosecant square phi. We can write it as 1 plus cot square phi. So already we got tan phi. From tan phi we have derived cot phi, which is nothing but 1 by R dr by d theta, and since it's cot square I will write it whole square. If I just multiply this 1 by r square inside, what I will get? 1 by r square plus 1 by this r. If I square r square, one more r square is there from outside. So what I will get? 1 by r power 4. 1 by r power 4. Where it is? 1 by r power 4. And what is the second term? dr by d theta the whole square. So what is it? 1 by p square. So they may ask you to prove this length of perpendicular from the pole to the tangent. And sometimes they will ask the simplified version. That is, if you put u as 1 by r, the above equation will become 1 by p square is equal to, so 1 by r means this will become u square plus du by d theta the whole square. Because if you differentiate u with respect to theta, what you will get? The term 1 by r power 4 dr by d theta whole square. In that place, you will get du by d theta the whole square. So this is a simplified version. Most probably they'll ask this only. Okay. So let me show how you got this du by d theta whole square. If you differentiate u with respect to theta, what you will get? Du by d theta. 1 by r differentiation is minus 1 by r square. And then r with respect to theta. So this is du by d theta, which implies, what is du by d theta? The whole square. This minus will become plus 1 by r power 4 dr by d theta, the whole square. So that is what we have replaced here. So 1 by r power 4 dr by d theta, the whole square, we have replaced this as. So either they may ask you to prove this or the simplified version. 1 by p square is equal to this 1 by r square plus 1 by r power 4 dr by d theta the whole square, which is nothing but the length of perpendicular from the pole to the tangent. Otherwise, they may ask you to prove the simple version, that is tan phi, that is equal to dr into d theta by dr, which is nothing but the angle between the radius vector and the tangent. Thank you.